Live? Cool. Okay. Today we are going to couple things. Somebody asked for where to practice kind of like Python knowledge, similar to the code activity that we did. So a couple places that I'll share with you guys. Then we're going to talk about changing Python versions or Anaconda environments. I'm going to do a SQL and Python notebook together. Then we're going to do the quiz and then talk about some sample projects for your, a little inspiration for your final project. And this one is the versions. Yep, okay. And let me make sure I don't forget to take attendance. Hello, jump. Yep, okay. Yep, okay. So a couple of places. There is found this, it's called realpython.com quizzes. So there's kind of like, there's like specific ones for like web scraping, but then like here's like basic data types, quick exploration. So this one seemed to be very similar, like, oh, like fill in the blank, and then, just like general knowledge of Python. So that's if you're looking to test more of your knowledge, check this place out. Then for like more interactive coding problem focused, I found this exorcism, which really sounds like exorcism. Not the best name, I feel like. And here they had like a Python track that just goes like very simple. Like the first one was literally like, oh, like print out hello world. And then here's like a little bit more like, oh, like, it has to-dos, and then you can run tests, and then you can submit it if you want to work on just like in general Python understanding. This one can be a good one. And, it has a little, it shows you like your progress and whatnot. So that's kind of cool. Both of them are free. I think this one probably has like a paid version. Not sure what that entails. And then lastly, if anyone's heard of LeetCode before, this is kind of when you start interviewing for roles. At least like if you're interviewing for anything that's like more technical, like programming heavy, this is usually the format that they're going to be asking and testing your skills. And I think they actually have SQL here as well. Let's see, problems. So if you want to like test your SQL, yeah, so here's SQL 50. And this is definitely like I've gotten questions like this in an interview for a data engineering or like an analyst role where they're asking like, oh, like how do you complete your query and whatnot. So LeetCode is great for that. And then I think I have the paid version of this. So I'm not sure if you can see the solutions. I think you might only be able to see the solutions once you've submitted a solution if you're not paying for it. But regardless, there's there's different kinds, and then a lot of times they like tag companies here as well. So like if you're targeting Google, you can go and see like what kind of questions have Google asked. So like people are reporting here like, oh, I got this question in a real interview. So LeetCode is really great for that. I wish someone had told me about it before I started interviewing, because like the very first time that I interviewed, which was with Google, like I interviewed for Google for like an application development role, and I hadn't even never heard of like technical interviews. And like now looking back, like it was like such a simple interview, but like since I had no idea what they were looking for. Yeah, it didn't go too smoothly. And then another thing I would say for like when you are prepping for interviews, I think some, like, I don't know about most, but like some companies, the recruiters, they will help you kind of like, hey, like this is what we're looking for, and like provide you some resources. But another thing, just like going on YouTube and looking at like technical interviews, like mock interviews, gets you kind of an idea what they're looking for, because it's not always just like, oh, can you like code this, but a lot of times they're looking for like, how do you work through the problem in your head, and then like, can you explain it to someone, like explaining to them like, this is what's the first thought that comes into my mind when solving this problem, and it's probably not the most optimal, but this is how we can improve it. And just like overall, they want to see like your thought process, and that's why they used to be called like whiteboarding sessions, and maybe they're still called that nowadays. Most of them are online, but like you would actually go into the office and like on the whiteboard like write code, which is like, it's good and not good depending on what the company uses, because like some of them use like proper code editors, but then some of them literally just through like a notepad like text editor, like it doesn't tell you like where the errors or anything like that. But yeah, check these places out. And yeah, and there's a ton of resources for technical interviews online. So, but definitely Google some of those things before you go into your first technical interview, so you're not completely blindsided for that, what's going on, because it's definitely very different from regular interviews. Okay, we're gonna talk about any questions on that. Cool. Okay. Talk about like changing Python versions and Anaconda environments. How this originally was formatted was like the library that we're going to be using later on with the SQL notebook. It was not compatible with like Python 3.10, but now I'm using Python 3.12. That's the latest, and that library is compatible, so we don't actually have to downgrade our Python. But I'm going to walk through how to add like different environments with different Python versions, because that's something that you might come across someday. But yeah, Anaconda Navigator. So this is the one we looked at. There's environments here on the side, and usually and this is really small. Let me see if I can make this a little bit bigger. Probably not. Configure Navigator. Ooh, okay. Maybe not. I probably can't zoom in here, can I? No. Okay. Well, I'm just gonna try to. So anyways, so home environments, and then here's gonna be like different routes, different environments. Create, clone, import, backup, remove down here. And whatever is here is everything that's installed in this specific environment. When you first download Anaconda Navigator, you're just gonna have like base parentheses root. That's just like what the current, I think it maybe uses the default Python that's installed on a laptop, or maybe it's just whatever it currently is Anaconda is using maybe. But this is basically like when you go like conda install something, it would just install it to base. When you want to create a new environment, so let's just say you're working on a Python library that is not compatible with the latest Python. So we would want to create a new environment because you don't want to mess up all your other projects. And this is a great way to kind of like, if you wanted to, or like you have two projects going on, and like project A is using, I don't know, 3.2, like MySQL 3.2 or Python 3.8, and then project B is going to be using 3.9 and like some specified libraries. This is how you can kind of separate them on your computer. So you're not like, you don't always have to keep switching back and forward, and it kind of keeps them like in a container for like that specific project, which you can still use. Like you can have multiple projects within there, but that's kind of like how to kind of control your resources. But yeah, oopsie, where'd you go? Why do things, okay. Anyways, so creating an environment. This sounds like jumping all over. Creating an environment, so coming here, environments, create an environment. You can name it whatever your heart desires. You can do like unicorn, but probably something descriptive so you remember what it is. So whatever I usually do is like, okay, Python, let's see, what do we have options here? So we have Python 12 or 3.12, 3.11, 10, 9, and 8. So if I were to do an 8, I would just do Python 3.8. And that's, we're going to create a new environment. And it takes a little bit. And you can also, I'll walk through in the navigator first how to do this, and then I'm going to walk through in command line or terminal how to do that. I find it just a little quicker to do it that way. Anyways, that's setting up. So here then when you come, why do you keep doing this? Something's going on. So down here, you can choose now like what environment you want to be using. And you can also install like different applications per each environment. So for example, here we can see in our Python 8, 3.8, we're missing like Jupyter Lab and Jupyter Notebooks, which are in base. And those ones, you can install them and install different things. And that just means it's going to be like, when you go open Jupyter Notebooks, it's going to be using that specific environment. So like I installed 3.12 earlier. So this one of Jupyter Lab here, I tried to install Jupyter Notebooks. I didn't get that far. So that's how you do that. And I usually use a just like terminal for this. Make sure that we can see. Let's do exit here. So let me look at so once you've installed Anaconda Navigator on your computer, you will have command conda, and this is how you can install Python libraries within like Anaconda. So like whatever you install with conda is going to be installed like on your Jupyter Notebooks, or you can also use like the conda interpreter in Visual Studio Code. But to create a new environment, we can do conda create -n and then my environment, and then you can put what Python you want it to be using. Let's see. Can you stop doing that? That is crazy. So let's do Python 3.11.9. So now I think it should show up here. So here it's just asking like, hey, these packages are going to be installed. We're going to do yes. It doesn't like take too long. And then and it shows you like, oh, to activate this environment, use conda activate. So conda activate my environment. And now whatever I run, see how it says my environment right here? Whatever I run here, like conda install, and here it pops up right now, my environment. So let's look at it. I don't know what this is doing this. That is so annoying right now. Okay, my environment. So let's see, do we have, Okay, so these are all the packages that are in my environment, which is not a lot. So we can, for example, see like pandas is not here. So if we were to open, so we'll do Python 3, and this is how you can also code with Python in just like your command line. So if we were to do import pandas as PD, it's going to say no module named pandas because it's not installed here. So we can do exit, and then we'll do pip install. And we can do pip install, or we can do conda install. When you're dealing with Anaconda, it doesn't really matter. So conda install pandas. And we should see it show up in here. Let's see. Yes. It's also going to install NumPy and PyTC. There's a couple other ones and whatever else is here. So executing done. So now if we do Python 3 and then import pandas as PD, it should work. There you go. And now we can do whatever we've been doing before. And this one still keeps jumping. And it should update here. So we had 16 packages available. Let me see if we look at this one. Not very fast. Now it says 31 packages. So we see that pandas was installed, PyTZ was installed, NumPy, where's NumPy? NumPy was installed. So that is how you can control your environments. Any questions on that? And so, you know, so being able to maintain multiple versions of Python and downgrade when necessary is important for compatibility, stability, dependency, management, collaboration, and testing. And that's also like if you are, let's just say you're like developing an application or whatever, and like you want to send it to your coworker and like they're using different Python version. And let's just say for some reason they're not able to upgrade their Python version, you can test your application with creating a new Anaconda environment and installing it with like the older Python version. Yeah, compatibility. And again, yeah, there like some libraries, because Python is open source and there's a ton of libraries out there. So whenever you go on like GitHub, you find like a very specific library. They might not be keeping up with the newer releases of Python. So that's like if they don't update it very often. Stability, dependency management, collaboration. Yep, yada, yada, yada. And then, yeah, so the virtual environments, like the Anaconda environments, those are like one way of doing your, like having multiple versions of Python on your on your computer. But you can also like, you could just install manually, like go to python.com. I think it's python.com, python.org. Definitely not that one. Let's see, install Python. Download Python. So yeah, so like this is the latest one, which has been like fully tested. And then we can see here is like 3.13 is coming. 3.13 is going to be coming in November. And I think you can still, yeah, you should be able to like download this and like use it, but they're kind of saying like, hey, like it's not fully tested. So whatever bugs you find, like let us know about that one. But we could go and install 3.7, 3.8, 3.9 from here. But that's just like a lot of work, manual work. So yeah, virtual environments. Then there's also pip env, and then there's virtual environment, vn. So those are like the built-in modules that can also like help manage Python versions. I think Anaconda is kind of like, I feel like that's like the most user-friendly. It's like it has like so much support and like guides, and you can pretty much Google anything, and it's just like makes it very easy to maintain your thing. And it has a user interface, so you can see what you have instead of, especially if you're not that comfortable with terminal. Anaconda is good. Then there's pyenv. So yeah, this is a command line tool, so you would kind of have to know how to use command line to do that. Another thing, Docker. It's like a containerization platform. Basically what you can do with Docker, and I don't think like, maybe like if some company that you end up working at is using it. I've used Docker very few times, but basically what it does is like, if you're trying to run some app, or it's like a very lightweight virtual environment that like, if I develop something on Mac OS and then I want to run it on Windows, or I want to run it on Linux laptop, I could create a container, like a Docker container, and then run it within that. And it kind of just like, puts all the requirements and any dependencies into that container. So you're able to run it in an isolated environment. I find it super confusing. I still have not like fully grasped the whole thing. I know it's like, it can be very powerful and helpful in certain scenarios, but have not dived in there too much. So probably not something that you guys will be playing with super soon. But yeah, I would recommend Anaconda for managing your Python installations. Any questions on this? And honestly, like if like when you're just like first time super beginner to Python, you probably not going to come across too many projects where you would need to have multiple different Python versions. Because if you're like looking at pandas and matplotlib and seaborn, like these are libraries that are very well maintained, and they're like always going to be up to date with the latest. It's mostly just like for those like little less known libraries, any like custom libraries where you would probably counter this with. But it might be also like if your workplace, like they've been using 3.8 and they like whatever libraries they're using are not using the latest Python. So, but yeah, just good to know. Yeah, so we're not going to be downgrading our Python because we no longer have to, because MySQL connector is up to date and it does work with 3.12. So we're going to go through, where did I put this one? Yep. So from the Google Drive, Python_SQL notebook is going to be the notebook that we're going to be looking at. You can, again, open it in Jupyter Notebooks locally. Another thing you can do with the navigator, very similar to, okay, slow. So yeah, you can use Notebook, Jupyter Notebook, or then like Jupyter Lab. This one looks exactly the same as our Anaconda Cloud, but it's opening your local like directories. So this is where, or like you could, like it's pretty much same as Jupyter Notebooks, but don't really even know what the difference here is. It looks like Anaconda Cloud, but it's your local thing. Probably something to do with the limits of, yeah. But again, I don't know why you wouldn't just use notebooks. Anyways, that's something you can do. So Python _ SQL from the shared drive, open it in Anaconda Cloud, or open it in Jupyter Notebooks, or open it in Visual Studio Code if that's what you prefer. And the very first thing that we're going to have to do is install MySQL connector. So you can just like uncomment this line and run it. So for me, when I run this, it's going to say already satisfied. But for you, it should show like a bunch of text, loading, whatever stuff. And then after that, we can run this. And if it says like, oh, can't find library SQL or pandas or whatever, make sure to run this first. And if it can't find pandas, you can run pip install pandas. Then I also have warnings imported here, which is not something you need, but there's a couple of things this was complaining about. It wants us to use like a different SQL library, and I just didn't want to mess around with that. So we have proper class today. So we're just going to be using this MySQL. It like wants you to use like SQL Alchemy, which I'm not too familiar with. So we're just using MySQL connector. And here is going to be a config where we have user and password, and then the host, how we can connect to the database. And this is not the best practice to have like your username and password here in code like this. There are better ways to do it. You would have a separate config file that you just kind of load and read that way. And that's another thing. If and when you get around using like GitHub and version control, and if you're publishing any of that to like your public repository, make sure to not include like sensitive information like your password and whatever, because it is a really, I've done that one time, like I wasn't planning it on publishing it or whatever, but like one of the commits, I had my whatever, like it wasn't like my email password or anything like this, but like it was a password to something, whatever. But if it's in your commit history, even if you later on move it to like a different file that's not getting committed to the version or like getting published to GitHub, since it's version control, one of the previous versions is going to have it. So something to be very mindful of. Don't do this. But this one is, I don't know whose this is, but it's some kind of public database. So we can do this right now. But especially with like any company credentials, don't commit those. So this one is just, we're creating a little dictionary here. And then we're going to connect to the SQL server. Did anyone have any problems with this before we move on? Anyone who is following along with installing the MySQL connector? Everybody good? Just stop me if I'm going too fast. So we're going to be doing mydb equals mysql.connector.connect, and we're going to be passing in a config here. Then cursor, and this is potentially something that you guys are familiar with. Maybe not actually. The cursor is kind of Python Java thing, I think. But yeah, this one, I don't even know why it's called cursor, but mydb.cursor and then cursor.execute is how you can execute. I think it's pre-saved queries is how you use the cursor execute. But this one is show tables, and then for table in cursor print table name. So this one is, we connect to the database, and then we're gonna run this. And I feel like there's a name to this, I just don't remember it anymore. But yeah, pre-made queries. And then we're just gonna wanna print out every table that's currently in the database. So show tables, queries all the table names, I'm gonna print them out. So this one, which, hold on, let me do this again. Clear outputs. There we go. Okay, yeah. So we have comments. I want to say this is supposed to be tweets, but it's tweets, whoever made that. And then we have user table. So this should look familiar to you guys. Select star from tweets. This is something that you guys learned in SQL. Very, very straightforward query. And what we do with that is, so we have query equals select star from tweets. Results data frame equals PD, so pandas. Read SQL, and we're going to be passing in query and then my database. So my database is the connector here, or my DB is connected to the server. We're passing in query and my DB. And then I'm going to print out. So this is what we have in, we have 6 rows. We have 4 columns. And this acts exactly the same as how we've been playing with data frames previously with pandas. So this is a regular pandas data frame, but it's coming from a SQL database. So we can do results underscore def dot head. We can do results df dtypes. Oh, did I not run this? Is it respelled out? Results. It's the same thing as if we had read it from a CSV file, or if we had read it from a URL. That's the only difference here, is that just read is like loaded differently. So here, let's do for each one of them. So like we're gonna query, it's like start from comments. Then we're gonna store that in comments variable. So pd.read SQL, and these are all the same. We're gonna do the tweets again, and then users. So running this, and let's look at users. So here we have 7 rows, 3 columns, the user ID, name, and then login. Look at comments. We have tweet ID, user ID, message. And this will be comment ID. Tweets. This is the one we already looked at. The same thing. We can look at comments.dtypes. We can see ID is integer, because that's one thing that we notice here, like users ID is an integer, and that's what we see. Users tweets. The user's ID is an integer, but if we go, and that's the same thing in tweets, user ID is an integer, but in comments, the user ID is a float. Why that is, not sure. But again, we could change that. Whatever we do, comments, and then user ID as type int. Now we have to make this comments user ID equals comments. And now if we look at comments, now we've changed it into an ID. Same thing with dtypes. Now it's consistent everywhere. Same stuff with that we've been doing. Let's see, what do we want to do with this? So again, putting your SQL knowledge into use. If we wanted to join, let's just say we wanted to see the user name for like what message they posted. So we can do, is that we do multi-line query? Strings, yeah. So we can do query equals, and then we're going to do 3 double quotation marks. So we select CID as common ID, UName as CName as CMessage as message, and then from comments C left join users U on C user ID to UID, and we'll just pass it in the same way before pd.readSQL query and mydb. So now we can see common ID, the name. These are Elizabeth said these, Mike, Thea, Thomas, Kate. Any questions on this? What else? You guys give me a query since your SQL knowledge is probably a little more fresh than mine. I have not touched SQL in like years at this point. So what can we do with here? What's a fun query we can run? There's not too many columns, honestly, but anyone have a query for me? What can we do here? We could look at the posts the same way. So if we want to see who posted what, would we do that? See, very similar to this one. Say query. So do we want a comment ID from tweets? The same thing, yeah. So we're gonna choose, let's see, tweets. Is that a user ID? Yep, user ID. US name. T. So post. And why don't we also do the date? That's one thing. Did we look at tweets? Yeah, date. We could convert that into a date time if we wanted to do anything more advanced with that one. There you go. Post. Oh. Tweet. Oh. What did I do here? Yeah. Okay. Date as date. And there we go. Name. Elizabeth said nachos, tomato sauce, mincemeat, and cheese. Thea, Thomas, Oliver, Kate. So everyone has one post. But yeah, that's how you pair up Python and SQL. If anyone has a fun query to run, let me know. Any questions on this? And here in Anaconda Cloud, you can see the SQL queries or strings they turn into like the colors. If we were to do like query equals, because we can't just do, can we just do this? I don't think we can do this. Yeah, see, so like this is how you're gonna know that it's not properly, you don't have the proper syntax here because the select is not red. Not all IDEs do this, but Anaconda Cloud is nice and does this. So if we add 2 here, now it turns into red. Oh, and one thing I did want to show that I keep forgetting to show is if you do pd dot and then you hit tab, it's gonna give you like everything you can do. It has like kind of like autocomplete for you. And then it even has, what is it? Read CSV. Yep. And then I think, yeah. So if we do come here and then we hit tab, it's gonna pull up everything that's in this folder. So we should be able to see sales underscore right here, sales data sample. So it can even complete that for you. And this is the one that we were looking at last week. But yeah, it has some nice autocompletes. And then of course, this is what we've seen a couple examples of, doing comments dot group by user ID. I'm going to select tweet ID, not tweet ID. That's not the one. Well, actually, anyway, this doesn't make any sense in reality, but just to show. And if we wanted to look at the mean of the tweet IDs, again, it doesn't make any sense, but that's how you get user ID. And then for each user ID, this is the mean of the tweet IDs. And I think in SQL, it's very, you do your group by, and I think to get an average, or like mean, you would do average or something like that. Don't remember exactly, but similar stuff. Group by is used somewhere. And then for the databases, you have to like close it. Like this is like an open live connection that we did here. So we want to close it once we're done with everything. So we'll just do mydb.close. That way we don't leave any open connections. Any questions on this? This looking familiar for you guys? Remembering your SQL? But yeah, you can play around with this and then, I think there's probably, if we were to look, let's see, SQL database sample project. Oh wait, let me do database sample project Python. Reddit is always a good source. Let's see, what does it say? Projects, Python SQL. Yeah, there's a lot of things that, sample projects that you can combine your SQL and Python knowledge. I really want to find another database I could read. Don't want this. But yeah, something to look at. No questions on this? But yeah, it's really not that much different from what we've been looking at since, like, we've been playing around with pandas. Just a different way to load your data. Okay, let's see. Okay, we're gonna do a 10-minute break, and then we're gonna get into the Python quiz. Yep. Okay. Be back by 7 o'clock. Central Time. Cool. Okay. Let's do. We're going to do like a little. Let's see, where is my? Yeah, this is mostly focused on like Python knowledge, a little less on like visualizations and business intelligence stuff. This is basically just like focusing on Python syntax and knowing how to code in Python. So that's what we're going to be doing today. I would like this to be interactive, so you guys are going to help me out how to write these and solve these. It's kind of like a group quiz. So I think if you were here for Kahoot, we went over how to start a function. So who remember how to do that?
DEF.
Yep. And here again, we can see it's lit up green. So that means it's like a valid thing that we're looking for. And we're going to name this myfunc1, which is not the best name, but this is what we're going to do. And then we will need our parentheses and a colon. And then what's going to go inside of this function?
I mean, do you do like parentheses hello world? Is it that simple?
Yes, it is.
Oh, okay.
So, yep. And this can be double quotes or single quotes. And then let's run this and we're going to test out myfunc1. Oh, and we need parentheses here as well. And we get hello world. Easy peasy. And this is what we were kind of talking about in the very first class, how simple Python is. It's very, English friendly and requires very, very little of extras, squiggly brackets and whatnot. Okay. Question number 1, done. Okay. Define a function called myfunc2 that takes in a name and prints hello name. So def myfunc2, and what needs to go inside the parentheses? So when we say what that takes in a name, that means when you're calling that function, you should be able to pass in a variable that can then be used inside the function. So we can call this variable anything, and you can include data types in Python 3. They're not necessary, so we can literally just put name. So yeah, a name of someone, but since we want it to be a variable, which means it can be Rosenda, it can be Melinda. So we want it to be a variable that can be changed when you call it with something else. And what goes inside the function?
Do you have to, I don't know if it's called an array here, but do you have to do an array of like all the possible names?
Nope, we're just gonna, the way this is gonna work is you call like myfunc, so we're gonna do myfunc2, and then, for example, we would pass in Melinda, and then it would print out, hello, Melinda. But how can we do that in here?
Is it something where like you would do like the string hello, comma, or hello, and then plus name? I don't know.
Very close. So there's a couple ways we can do this. So my preferred way is doing the F string
Okay.
because it's very straightforward. So we can do hello, and then we will put squiggly brackets and name.
Oh, okay.
So this is one way, but what you were talking about, so this one works. We can also do my func2 name. We could do, I think it's hello string and then format. Let me look this real quickly because I don't remember this. Python string format method. Yeah, here. So format and then price. Yep, this is how we can do it. I think you don't actually even have to. Yeah, this is what I was looking for. And if you can also do this way. So you do a string. There's something uses those things. I don't remember. Format, and then we could put a name in here. Let's see, does this one? Oops, don't need that. And it still works. Do Rosendo. Perfect. And now it's using this one. And we could even name these different things. Let's do to see. There you go. Yeah. So string dot format, and then you pass in your variables in here. This is my preferred way because you don't have to remember all these things. But there are different ways we can see here. So you can do my name is F name, I'm age, and then format, F name equals John, age equals 36, and my name is 0. I think this used to be like the way to do it until I think they added these other ways. Because I remember learning this in a very beginning that you just use like the index and then dot format, and then you just pass in your values. But now you don't even have to put the index in there. It just does this. So yeah, lots of ways to do the same thing. Okay, question 2.
I think I like the first one because it reminds me of when you're doing like an email setup and you plug in the fields. It kind of that maybe a better way to remember it or something. I don't know.
Yeah, for me, this is just like all you have to do is put the F in the front, and then you just put the variables in squiggly brackets. I feel like that's the most straight up, and you don't have to remember any other like names. So this is my go-to always. But for some reason, like some of the examples that we looked at were using this. Either way works. Neither one is wrong. Okay, question 2 down. Doing great. Okay. Define a function called myfunc3 that takes in a Boolean value, so true or false. If true, return hello, and if false, return goodbye. So we're going to do myfunc3, and then we can just call this anything. Let's see, value, and then what's going to go inside here?
Let's see. Is it a forced? It's not a forced. No.
The question almost like gives it away. It is simple. It's as simple as you think.
Is it true, like equal hello? No.
So we want to see whatever is passed in. So again, they takes in a Boolean value. So we're calling that value. So how this we're gonna we'll call function 3, and then we can put true, and then we can also do function 3 false. So when that value gets passed in, what do we have to check with that value?
Is it value equals value? No.
Not value equals value, but what do we want it to equal when we get hello? So we do if, yeah, value equals true.
Okay.
What do we want then?
We want print hello.
Yep. So we can do print hello, or this one technically it's asking for return, which doesn't really make a difference in this example. So we could do return hello, but either one will work in this one. And then what comes here? Rest of the function.
Else. Return goodbye.
Yeah, perfect. Let's test it. Okay. My function with true, we get hello. My function 3 with false goodbye. Perfect. That works. And we can even simplify this further. Something that you can do with Python is if we do like if value, that is technically already checking it. So we can just do if value, return hello, and we don't even need an else statement here, because when we come into a function, the first return statement it finds, it's going to jump out of that function and not going to execute anything that happens afterwards. So the only way we would get to return goodbye is if the value is not true. And the only way we would just get the hello is if it is true, and we would ignore the rest of this. If we run this, we're going to get the same. But it is, again, this is like kind of like a question between cleaner code versus more like easier to understand code. So I think depending on who your audience is, it might be more like, you know, if you're working with coworkers who are, all of you have just learned or started to learn Python, you would probably want to do like, oh, if value equals true, and then else, because it's like very clear what you're trying to do there. And especially if we're like working with more complicated code or bigger if statements, there's more code in there. It might be better to do it that way versus just doing this. But this is the shortest or like the simplest way you can do the same thing. Any questions on that? Cool. Okay, let's do number 4. Define a function called myfunc4 that takes 3 arguments, x, y, and z. If z is true, return x. If z is false, return y. Okay, we're going to do def myfunc4, and we take 3 arguments. So we're going to have x, y, and z. Oops. Okay, so inside the function, if z is true, then return x. If z is false, return y. So very similar to what we did before. What is our if statement going to look like?
So if z equal true colon return X with quotes around it.
We're just going to return X. Because if we did quotes, it would treat it as a, this is, well, yeah, it's a little misleading.
It's not the name, it's the value. Okay.
Yeah. Not return X as it is, but the value, like the variable X. But yeah, if it was like we wanted to return the letter X, then that's what we would do. And then else, we're going to return Y, right? And again, same thing that we did here. We could simplify it like this. So let's check my function. And let's see, X is going to be, and again, here's not like no data types, so we can make this anything. So my function 4, 10. So let's just say we're going to return 10 if C is true, and we'll return 0 if it's not true. So true, this one should return, oops, and run this one first. Returns 10, and if we do my funcs for 10, 0, and then false, we're going to get 0. So Z, and this is again like they need to be in the correct order here. And this could be anything. We could put hello, goodbye. Do the same thing here, and we will get the same thing as before. Any questions on that? We're doing great. Okay. Number 5, define a function called myfunc5 that takes in 2 arguments and returns their sum. df myfunc5. So since we're looking for them to return their sum, we probably want numbers in here. Technically, we could also use characters or strings because those can be converted into integers. But we'll go with numbers. And we can just do A and B. And what do we want to return here?
Is it like a sum function? Let's see. It'd be like an operator. Would you do, let's see, it's return parentheses F quote A plus B? No.
Yep.
Is that it?
A plus B. That's how easy it is.
Straight up return A plus B. Okay.
Yep. And yeah, there is a sum function, I think. So again, Rosendo, you got like the idea is right, but again, remember we're playing with variables here. But if we were to do myfunc and we'll pass in 4 and 5, and I forget to run this every time, we're gonna get 9. And if we did myfunc5, myfunc5, 10 and 5, we're gonna get 15. So yeah, it's almost always as simple as you think it is. Okay, number 6, define a function. Okay, this one might be a little trickier. Define a function called is_even that takes in 1 argument and returns true if the passed in value is even and false if it's not. So df is even, and we are going to we're looking for a number, and we'll just call it X. And what do we need in here? So there's a couple things that we went over, I think, in the very beginning that is going to help us do this. But this is pretty much going to be one-liner as well. So like return something. Does anybody remember? Something to do with remainders?
Like a modulo?
Yep. So what do we need with that? Do you remember what the symbol for that is?
A %? I have it in my notes,
Yep.
but I don't know how much I wrote down.
Yeah, that's correct. And what does so we're going to do X modulo.
Okay, so X divided by 2 or
Yep.
%2. Okay.
Yep.
Equals 0.
And
0.
Yep.
0.
Yep.
Yes.
Yep. So, let's check. Returns true if it's even and false if it's not. So if the remainder of X divided by 2 is 0, and this one's going to just do, and we could do like, this is an if statement itself, but again, we could do like if X modulo 2 equals 0, return true, else return false. And these both would work. Oops. But this is like itself, since we're doing a comparison, that itself is going to return a Boolean, so true or false. So either one of these works. Let's see, is even. So is even, do 10, true, is even, 3, false. So yeah. The same thing if we did this. The same thing. A similar thing with, again, not that this is like super complicated, but to make it even like super spelled out what's going on with this code, you could do this.
I'm getting a wrong syntax, and I'm not sure what I am not.
In this function?
Yeah, so I was doing the if, because like I understand if else statements, so I'm kind of like, even if it's not as clean, I feel like I understand it better. So X modulo 2 equal 0, colon, return true, else return false. I feel like I have it the same, but it's...
Where does it, this doesn't do squiggly lines, does it? I don't think so. What,
and then it has an indentation. Did I indent incorrectly or?
Yeah, so make sure, so if you remember, Python is indentation sensitive. Yeah. So you want to have one tab here. And the way you can fix it the easiest is like if you remove everything and then go to the next line. And it's going to indent it
that did it
for you. Working now?
It was lined up correctly, but I think I like had like spaces and indents, and so it wasn't like formal. Okay.
Yeah. Okay. It's, the indentation is like so funny because like in my previous jobs, some people they're like, oh, you need to use 4 spaces instead of tab. And literally like doing a code review, they're going to be like, oh, knit, like you have, because it's going to show whether or not you use tabs or spaces. Mm-hmm. And I feel like that's like the silliest thing. Because like, it's the same thing. Like you do 4 spaces or you do a tab, it's going to be the same thing. So, but yeah, you have to, and if you're coding with Python in like Visual Studio Code, that one's going to tell you, like, it's going to squiggly line where your indentation is incorrect. Okay. Jupyter doesn't, but it should show you like in the error message what line the problem is, at least. But yeah. Any other questions on this? And I think we did when we went the FizzBuzz example at one point, we used similar to this. Or exactly this, because it was, if it's, no, that was like, whether it's dividable by 3 or 5 or whatnot. Okay, let's do number 7. Define a function called is greater that takes in 2 arguments and returns true if the first value is greater than the second, false if it is less than or equal to second. So df is greater, and we're going to do arguments. Again, we can just do a and b. And what goes inside here?
If A is greater than B, colon, return true. Else return false. Else colon, return false.
Yep. And this one, if it was,
oh, here we go.
Because this one will like cover. So we'll do our tests here. So is greater. We'll do 10 and 3. Yep. I always forget to run this. N is greater than 3. We'll do is greater 2 and 5. False. And then what do we get if we do greater 4 and 4? We're going to get false. Yeah. So if it's less than or equal to second. Perfect. And if this one was like return true if the first value is greater than or equal to, we would just add our equal sign here. So then the last one would return true. Easy peasy, lemon squeezy. Any questions? And this one also, we could just do return A is greater than B. And we should get the same thing. True, false, false. Yeah. Because this, again, it's a comparison, so it's going to return a Boolean value. Cool. Okay. Define a function called myfunc8 that takes in an arbitrary number of arguments and returns the sum of those arguments. So remember, we use star args when we aren't sure on the number of arguments that will be passed in. So def myfunc8, and then what goes in here?
Star args.
Yep. Args. And then what do we need inside here?
Is it like a sum? Let's see.
Yep, that's
like a sum of star args in the parentheses.
Yeah, we're gonna do return sum, but we don't need to put the star in here. We'll just put args.
Args.
So now if we do, okay, run this. myfunc8. Let's do 1, 2, 3, 4. We're gonna get 10. myfunc8 5, 5, 5. We're gonna get 15. Cool. Easy peasy. Okay. Any questions on this? And this one, I think if we were to pass in, like, what happens here? It's not gonna like that because you cannot pass a string in here. if we were to do that in, let me look at, if we were to look at like what we looked at earlier, so we'll just do another one like AB, and we're returning, oops, return, oops, we need the df, my func 8, AB, return A plus B. And then we're going to do this one. Technically, you should be able to do my func 8. We'll do like 10 and A. Does this one? No, it doesn't. Will it let me do just 2? Yep. Oh, yeah. So this one, you can like, with this thing, you can concatenate. This one page is like hello. But you can't mix and match types here. You won't let you do that. But technically, and maybe it is actually only in Java or somewhere, because like in like, gosh, I don't know, Axie or ASCII, or I don't know how to say this word correctly, like Axie, ASCII, whatever it is. That one's like the symbol. So like a character, the numerical value is like 68. So technically you could sum up like characters and then just get like the integer value of them. But that's not here nor there. Just a fun fact. Okay. Number 9. Define a function called myfunc9 that takes in an arbitrary number of arguments and returns a list containing only those arguments that are even. So this is kind of like we're combining this one and this one. So what do we need here? def myfunc9. Gonna do the same thing. Star args.
One.
And then, so we're returning a list. So we need to declare our output list first.
So maybe return bracket args.
Yeah, so brackets is how we do an empty list.
Oh, just empty.
So,
okay.
Yeah, so we have to declare it first, like declare initialize the list first, and then we want to loop through the arguments and only add the args that are even. So how do we do that?
So I feel like we would do would you do if arg modulo 2 equals 0?
So close, but remember, we don't know how many there are, and we want to go through all of them.
Is it
so
like a 4 each kind of thing?
Yep.
Okay.
Yep. So we can do 4, and we can do like n in args.
Okay.
And then now we'll do what you just said. If, like, let me call this num, so it's even clearer. Num, if num modulo 2 equals 0, then what do we want to do with it?
I mean, somehow add it to the list. Let me see. Would you like add or append it? One is list, one is something else. Hold on.
Yep. The list is append.
Okay.
And I think the way to like kind of remember, so like this is 2 of the questions on the Kahoot was like about this. So when adding into sets, that one's .add, because sets they don't retain like their original order. and we don't have duplicates in there. So that one's add. So we're just adding it in. And then with lists, we kind of want to like append it at the end of the list because lists is ordered. So append it at the end. That's how I've kind of learned to memorize it, but I'll probably forget it. So append num. And then what do we want to return?
The bracketed list.
Wait. Yeah, we return the list. So out is what we're calling it right now.
Oh, return out.
Yeah.
So is out just naming the list? Or
so we could call this anything. We can do like return list. But the reason we can't call it list is because list, well, actually we can call it list. You can't call it, maybe I can call it actually list. If it shows up like, yeah, okay, we can call it list. And some, like we couldn't do, if it was a dictionary, you can do dic. Yeah, you can. I don't know why it's like this. Maybe it's because it's not. Or maybe they've changed that. I'm not sure. But you used to somewhere you can't like, because if it's like a reserved word in Python, like you couldn't call it def or you couldn't call it for because those are like Python variables. But yeah, we can call it list. So we'll do myfunc9 and then let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we only get our even values here. Let's do another one, myfunc9. And then we'll do 2, 4, 4, 4, 6, 8, 9, 3, 6. And we only get. And again, since it's a list, it like we have the same order as it was here, and duplicate values are allowed. Any questions on this? Okay, doing great, everybody. Okay, last one. Define a function called myfunc10 that takes in a string, returns a matching string where every letter is uppercase, every even letter is uppercase, and every odd letter is lowercase. Assume that the incoming string only contains letters and don't worry about numbers, spaces, or punctuation. The output string can start with either an uppercase or lowercase letter so long as the letters alternate throughout the string. So an example of this is if, we'll do banana, and this is, hold on, let me just change this markdown, banana. Then the output should be like BANANA. So every other one is uppercase and every other one is lowercase. So def myfunc10, we're taking a string. So we'll just do input or whatever. Doesn't matter what you name it. So we need to, in order to, this is going to be tricky. We're combining a lot of things in here. And there's a couple of things that we haven't gone over, I think. But basically what we want to do is we want to like break this string into characters. And then we want to put them into a list in order to like look at them individually and then be able to get them back in. We could technically just like append to a string, but one way to do a list. So let's just do like list equals empty list. And then how can we loop through the characters or the letters?
Well,
so something that we'll probably need to look at is kind of like the index of the letter in order to know whether it's even or odd index.
Well, I'm looking at my notes from night 3, and we talked about, I don't know, there's like matching here, but I don't know if that's quite the same thing.
Yeah, we don't need to use regex for this. It's just, we're just gonna do it like plain and simple, just look at the index, how we've been looking at even and odd before. But to go through, like, to get the index, so we're gonna do for I, and I is just gonna be the index of it.
Okay.
And then in order to get like the end range of, like, from 0 to when do we need to go? So we're gonna do the length of the input, so like length of the word.
Okay.
And how did we do that?
Is that like a string length? No.
This was one of the Kahoot questions. How to get the length of a variable?
Oh, len parentheses.
Yep, len input. However, this one, so for I, the way you do like the range is we're gonna do for I in range, and then we're gonna pass in the length input. And we could also do like, and will it let me do len here? It used to not. So we could do like len input, possibly, and then pass it in here. If we were like, for some reason, if we were to use like the length multiple times, we could do it this way. And then colon, let me test this. Will this work? Print I. I think it works. It used to not let you do that. So in very, let's see, 5. Yeah. See, it does not like that. But it lets you use list. Very interesting. Anyways, we can call this L. Doesn't matter. And yeah, okay. So inside here, we want to see whether or not the index is even or odd. So how were we looking at even or not earlier? We do the modulo. So we're going to just do I modulo 2 equals 0. And then what do we want to do when the index is even? Let's just say, well, we want it to be a lowercase because it didn't. Oh, is that what it says? Oh, no. Every letter, even letter is uppercase. Okay. So we want this to be uppercase.
Would you return like, I have it here as like bracketed, like uppercase A to Z, or is that?
We won't use regex here. So yeah, just we just want to turn this specific letter that we're looking at into an uppercase.
Oh, is it like
yeah.
I don't have it in my notes, I don't think, but like, is there something like, I'm thinking of CSS, like a text transform uppercase or something like that?
Similar, but it's even simpler in Python because remember, Python is simple. So first we want to do, list, again, we want to be appending these into the list. So list, append.
Okay.
And then to access the letter from our string at that specific index, remember how to do that?
No.
So we're going to do input and then bracket I. So this is going to be, so when I equals 0, from the input, we're going to access the 0th index letter. And then we want to turn it into an uppercase. And in Python, it's just .upper because Python is simple. And then else is going to be lowercase. So we do the same thing, list append, input, I, lower. And then to return this is not something we've learned. So we're going to do return empty space, join, and then we're going to pass in the list. And another way we could be doing is like, let me do this one and then I'll do the other version. So we'll do, let's do our banana first. Here we go. Here's our banana. So whenever like we get here, so let's just say I equals 0. We're going to look, oh, is the remainder 0? It's got to be true here. Then we're going to look at input. So banana 0 index is going to be B. The next time around, we're going to be looking at I equals 1. We're going to do the first or one index 1, which is going to be A. That's how we do it. Any questions on this?
So sorry, I'm just trying to understand how we're defining like that first one being uppercase being like the first digit and then the lowercase is the second. I'm not quite equating how we're defining that.
So
or how we
I is like our index. So when we do the len input, this is going to get, so we'll add a couple print statements so we can see. So print L, and we'll do F, let's see, the length of input is L, and we need here, and then we'll do print F, the current index is I, and the letter at the ith, the I index is input I.
Okay.
So let's, no, not in here, in here.
I think
so now if we print this, we're going to see, so the length of banana is 6, the current index is 0, and the letter at index 0 is B. So I is 0. When I is 0, we're looking at the first index, the 0th index of the input, so banana. So when index is 0, the index is, so the letter is going to be B. When it's 1, it's going to be A. When it's 2, it's going to be N. 3, 4, 5.
Okay.
Does that answer your question?
I think so. And then I was just kind of rereading it, and it's saying for like each index or letter, if that's divisible, if that placement is divisible by 2,
yep,
no remainder, then that's an uppercase. If it's not, then it's a lower. Okay, so I was kind of rereading it and I got it, but then the way you just spelled it out, I think is really helpful too.
Yeah, so that's what we're looking at. We're looking at the index, the current index, whether or not that index is even. So it doesn't look at like the letter, it just looks at because what we were looking like every even letter and every odd letter. So it doesn't really care about like the letter itself. It just cares about the placement of it.
Right. Okay.
Anyone have any other questions on this one? And let me show a different way of doing this that we don't need to do. We'll need that. We don't need a list. We could do, so let's see, we'll do output equals nothing or like empty. And then we could do output equals plus equals input I upper, and then else we're going to do upper lower, and then we're going to return output plus. I think this should work. Let's see. Yeah. So basically so here we defined a list, like an array, where we're putting our items in when we've transformed them. And the dot join is like, it's going to take a string and then, or this is, the dot join takes all the items in an array and is going to join them together based on what is here. So this is going to be like the divisor. So like if we put period here, then it would join them with the period. Or if it was like empty, we're going to get here. So that's what the join does. But here we're doing a output equals empty string, and then output plus, so the letter just like added together. We're going to put the letter in there, and we're going to get the same result here. Questions on this one? Questions on anything else here? I spelled this wrong. No, I spelled this wrong. Question?
Is there a way to print out that quiz that, we just kind of took together in a Word document without having to go back and review the video, in 2 days or whatever, if we want to look at an example? I guess I'm just, and or
this
will
notebook?
Yeah, or it'll just be saved in the notebook that we can reference.
Like, do you want it like with the answers or like without the answers?
I mean, both would be good. And again, I'm looking at it from teaching it to the younger generation and trying to adapt to, I just liked how you've gone over it and done it together. And I'm trying to sit into the data analytics Python class where it's a math teacher teaching herself Python. And like, my question was, how long have you been programming in Python and how easily you do this? But, teachers trying to teach this to, and I know I'm kind of an anomaly and trying to adapt what I'm learning to help another teacher deliver, in a meaningful, because,
yeah, I'll definitely post the answers as well.
Okay.
And I can like output this or like print it out in a PDF or whatnot if that's helpful. Like if you don't have a way to look at the notebook or like open the notebook.
Well, I'm still trying to get that access within the school, and I think they do use that Visual Studio Code where, the Anaconda. I mean, I can't practice this at school on a device that, there's just barriers to what we're allowed to do and the time that I have in my day job to, practice without getting on my hotspot. I don't want to take time, but it's just those technical things that I'm just trying to adapt.
Yeah, I can definitely just put this into a And I think there's ways to actually, I could technically upload this into, which we're going to look at example projects in a second, and that's going to make more sense what I'm about to say. But like, I can upload this notebook in like Kaggle, where you can look at it as it is right here without like, that's just like a website. So we can do that, but also I will post the answer key, and that can be opened in Anaconda or Visual Studio or anything that allows you to open a Python notebook. But I'll definitely make sure to make one that's accessible without downloading anything to your device.
Okay, yeah, because even if you just put it in the class, where all the other notebooks are in each class, that I was able to at least access that at school, and I'm just trying to still get access to the YouTube videos to rewatch and, kind of follow along and do, but I'm trying to do it within our own school setting too.
Yeah. And you don't have access to the YouTube videos?
No, I do.
It's just blocked in school.
Yeah, what we're allowed to view, and I just
right.
Again, I could do it at home at night when I'm on here, but when I'm inside the school's network, but I also have to do my full-time job at school, so it's not like I can, play on the network and
yeah,
just in the short turnaround time. This summer I'll have lots more time, so I may retake the class even this summer, just again to be able to experiment more.
Yeah.
Session.
I remember our school blocking all the fun websites.
Right.
But
right.
I find it really interesting that they block you too, because like how much learning material is in YouTube.
Right. Well, and I'm not saying they do, but just locating it and getting it and the time, during the school day. But it's more the getting the software downloaded and being able to test. I mean, I just can't download and load on a school device, like I can't get Slack on a school device. So I have to do it on my phone and look through, and if I could just have Slack on my desktop, that would be nice, but I can't.
Yeah. I can would it be helpful like if I just put like a Word document with the links to the YouTube videos on the drive?
That would probably just, time saving. And if when I go meet with the other teacher, just again, it's more for reference down the road. I'm not trying to, slow up everybody else's learning, but I'm just trying to, again, grow the teaching of it and the skill development, within the high school level.
Listen, the America's future is important, so we will do it for them.
Appreciate it.
Yeah. Any other questions? And if you guys have like anything from previous lessons or anything that you're having problems with, we can absolutely go over. We'll do a 10-minute break, and then we're going to look at some example projects. And then if you have any questions on the project, setting up Anaconda, setting up Anaconda Cloud, anything like that, we can go that over, because again, the final project is going to be due next week, and just want to make sure that you guys have enough time to complete it, and don't leave it at the last second where you're no longer going to have like, you can't ask questions and you realize like, oh no, like my Python is not working with Anaconda. So definitely ask those in class or ask them in Slack, and we'll go them over. But yeah, we'll do a 10-minute break, and then any questions, bring back after the break. We'll go through some example projects. Be back by 8 p.m. Central. Okay. We are going to look at some example projects for your final projects. We were looking at Kaggle last week to like search for a sample data sets, but there's also a sample, like kind of like sample notebooks, sample projects that you can get kind of ideas on what to do for your project, but just make sure that you don't do exactly what they do here. Just use it as an inspiration. But for example, on world happiness, because that's what I was looking for. So this right here is a notebook. So we can say notebook. So exploratory data analysis 2019 world happiness report. So here's like a little bit about, can you guys see this? This one's, can I close this? No. Okay. Anyways, table contents. There, perfect. Okay. So about the data set, like overall rank of the rank of the country, career or region score. So it just tells you like a little bit about the data set, like each one of the columns. And then it's an actual notebook. So here, oops. And this one, I think we can, well, this one, you can download this, like edit my copy. You can either do it here on Kaggle, or you can also download it, open it in Jupyter Notebooks, Anaconda Cloud. But Kaggle kind of has like a code editor in here. But here we could like, okay, run this code. It looks like it's very slow. So might be better to just download it and open it locally. But we're not going to look at this right now. Anyways, we're just going to look at it here. So importing essential libraries, importing NumPy, Pandas, Seaborn, Matplotlib, and then also filtering out warnings. So these are all the same libraries that we've been using so far. So reading the data set and assigning to the variable df. And this might be like having these little like titles, disclaimers, subtitles, whatnot, could be helpful to even you. Like if you do this project and like you don't look at it for, I don't know, let's just say you just don't look at it for like 2 months and then you come back to it. It's like putting little notes for yourself. And again, for somebody who has never seen Python and wants to see this, you know, this could be nice for them. Reading the data set, assigning to a variable df. The same thing we're doing here, pd.readCSV. Taking a look at the first rows of data, looking at the head. And by the way, Finland has been named the happiest country in the world for like 7 years in a row. And people keep asking me, why do I live in the US? And I could not tell you because I'm crazy. But Finns are very confused. There's like a really funny meme about that because Finns, like in general, they're not very expressive or like emotional. So like there's just like a picture of a guy who has zero emotion, and they're like, Finland has been named the happiest country in. Yeah, it's funny. But yeah, here's our head, and then again, checking the shape, looking at the info. This should all look very familiar to you guys. We've done all of this in our examples. Getting statistical summary of the data. So this one, .describe.t, actually don't know what that does because it's different than just doing describe. So it looks like, oh, it's just transposed, I see, which sometimes that makes more sense. Yeah. So getting the count means standard deviation minimum, maximum for every numerical column. So this one also should look familiar. But yeah, this one actually looks nicer when it's transposed. So maybe give that a try on your data set or your project. Checking for the missing values, df.isNull.sum. no values. Checking for duplicates. So this is kind of like when you go and select your data set from Kaggle or Google or data.gov or wherever, I want you to like leave these in there. So like when you're doing your little checking for duplicates, checking for no values, because the data set that you're going to choose is probably going to be pretty clean already. It may not be, but probably is especially if it's like ranked really high in Kaggle. You might not have any null values, but I want you to include here like, hey, I checked for null values. There's nothing that we need to do for them. And even if you want to go crazy and include like, oh, if we did have null values, here are some recommendations how to fill them. Like for country of region, you can't really, those are probably like, if the country is empty or null, like we're probably just going to drop those, because if we don't know what country it is, it's not going to tell us anything. But like if the GDP per capita, like, I don't know, you could do, probably can't really do a mean because countries are different, but you could look it up probably. But you know, like for your data set, like if you think there's a way to retrieve the null values, you can put a little like, hey, this will be my recommendation to fill null values if they were in the data set. Checking for duplicates, no duplicates. And again, if there were duplicates, we would get rid of them. Data visualization, so we're doing PLT, figure size, Seaborn, SNS, dist plot, DF score. Put in the score and then show. So here's just a histogram with a distribution line. So looking at the score, NASLA one, and then we have PLT scatter plot, social support, and score. And I think this one makes sense. The higher the score, more social support you have, you see a nice correlation there. Then we have GDP per capita and score. And there kind of also we have a correlation in there. Life expectancy, similar. Freedom to make life choices. Yep. So yeah, so here's one example. Ooh, what is this one? GDP per capita and social support. So there's a hex bin. So again, you're gonna get like, you're gonna see examples, you're gonna get some ideas how to visualize your data set. Like I haven't really seen a hex bin before, but that's kind of a cool. And then here we have scores of the happiest 10 countries. I really like, it's so crazy to me because it's so cold in like Finland and Denmark and Norway. And you get no daylight during the winter. And like, you know, that's really important for mental health. So they're just doing so well with everything else. Crazy. Ooh, Sweden down here. Very interesting. They're a little bigger country though. Maybe that explains it. So yeah, there's example. And again, how you find these notebooks, we can just go Kaggle and then let's just say, what do we want? So that one was like EDA on NLP student writing. Let's see, what do we find here? And that's what you want to look for when we're searching it, notebooks. That's where you're going to see like examples, get inspiration. What do we have here?
What did EDA stand for?
Exploratory data analysis. Is that right? It's somewhere in here. I want to say in here. Data cleaning. I think it's exploratory data analysis. I'm pretty confident. I'm just going to look it up because I don't want to be lying to you guys. Exploratory data analysis. Okay, got it right. Cool. Which just means we're exploring what's going on with it before analyzing, but also includes like analysis and visualization in most cases. But that's a nice keyword to find the kind of projects that you guys are going to be doing to like get ideas and see examples. Show hidden code. Okay. So this one's doing a whole lot of other stuff. Let's look at our 6. Oopsie. Okay, excuse you. Why aren't you working? There we go. Okay. There's another one, again, on the same, may or may not be the same data set. So this is for rankings. Again, same. They give a little overview of the columns using same libraries, pandas, numpy, seaborn, matplotlib. Okay, so this is actually using the exact same data set as the other one was. So this was the World Happiness 2019. So here we are looking at, so highlight max, and this one is putting like these highlights in the data frame. So here we can see like the highest score in each column is highlighted with green. So df.style.apply highlight max subset on all of these columns. And this is return background color lime green if the else nothing for v in is max. Yep, that's kind of cool. Very interesting. Now we're again checking shape, finding out attributes which are highly correlated to each other through heat map. So doing a plt.subplots SNS heat map. So what can we see here? Generosity with GDP, score, healthy life expectancy. Yeah, there's high correlation there. Social support. Yeah. Here's our pair plot. This is one of that we did look at. One of our notebooks. So can we see the generosity? I wouldn't say it's like a super high correlation. There's a little more. Which one is this one? They don't make life choices. And here. Interesting. These are kind of interesting. What's going on here? Score and yeah, that's just overall rank. That makes sense for sure. All right, top 10 countries with each attribute. So here's this, on Monday we looked at how to create that kind of like a dashboard with PLT and rows 2 and columns 2, doing a bar plot in the first one. So this is very similar what we did on Monday. So bar plot in first one, bar plot in second. Okay, so it's just bar plots, just different things. Region, GDP per capita. There's another one, generosity, perception. And here you can also get like ideas on the color palette and, you know, formatting things and whatnot. So you can make your project pretty. Now I want to give a category to each country as high, mid, low, according to their happiness score. So this is another example from Monday where we looked at the phone prices, and we did like the feature engineering where we assigned whether or not it's a budget phone or a luxury phone or a premium phone. So this is similar here, like we're adding a category. Add score. Is that what we're doing? No, we're not actually adding it to the data set. Range difference. Yeah, you could do that. Looking at the info. This is probably something you would want to look at a little earlier in your project. But again, we've seen that before. Oh, here we go. Okay, finally adding a new column category to a data set, distributing the levels high, low, and mid. So here, category, append low, append mid. So this is like a simplified version to do adding. If we look at, let's see, let's look at the one from, where is, not in project walkthrough. Yeah, this is the completed one, I think. Yeah. So here, this is how we added the extra column. So an example of a one-liner where we're using the pd.cut, but these both accomplish the same thing. So when you're doing your project, like by no means does it need to be like the most advanced code or nothing. What I just want to see is, do you know how to do this? And I don't care how you get it done. So this will be an acceptable way to do it. We're using a for loop, an if statement. This is basically just looping through each one of the scores and then adding the category to a list in order. And then we're going to be just appending, like we're assigning that list to the category column. So it's just going to be in order. And that works. But here it's kind of like, you don't have to like keep track of the order or anything like that. We're not doing a for loop, which I'm sure it's doing it on the background. It's looping through them, but one way to do that. Questions on this? Questions on anything? If you have any question at any point, just stop me. And what else are we doing here? So we'll be styling the data set as green zone and red zone. If the country belongs to the high category, then it's under the green zone. And if it's under the mid or low category, it's going to be the red zone. Interesting choice. But yeah, so this one was based on the score. So anything above greater than 0 and less than low. And what do we add here? Yeah, we calculated low. So we're getting the minimum plus round at DS score max minus min. Okay. So the difference between these would round it. So basically adding the range difference to the minimum. And that is our lower end. And then mid is low plus. So we're just adding another range difference. So those are the bounds. And then high is above 7.769. Here we can see which that doesn't. What is that high? If low. Is this correct? Not sure. That's another thing. If you are looking for an example and you decide like, hey, I'm just going to use whatever they did, they might not be right. Okay. This is just random people making these. So be cautious. And same thing, if you're going to be using like ChatGPT, which you are allowed to do so for sure, but you want to make sure that it is correct. Like, you need to know what you're doing in order to put, like, you got to know. Use your tools, but you got to know what you're doing. Otherwise, you might look a little silly. Because here it looks like it should be. Anyways, I'm not going to dive into that too much. But again, like, this is fine if you wanted to show something like this. But if we were to do this in like real world setting, does this really bring a value to us? Like highlighting every single country on this data frame based on the score? It might not, depending what questions we're trying to answer. But that's kind of like thinking, problem solving, like what are some like real world scenarios that we could use this data in, or like make business decisions. I want you to think that way. But again, like, I'm not going to be going through every single project and be like, does this make sense or anything? But, pretend like it's a real project. It's for the learning. What else are we doing here? Okay, we're looking at India. Then we are in the United States, United Kingdom, Canada, and then looking at all of them together. And then we have some visualizations. Oh, this is a cool one, and it's interactive. Wow. Oh, it zooms in. Oh my God, can you turn it? Wow. What is this made with? Crow. Graph objects, plotly offline iPlot. So here's a very cool example of what you can do with Python. Maybe it was hard to return. Can I return it back to the whatever it was? And you can download it. Very cool. This would be cool if the tooltip included this ranking of it. But yeah, very cool example of what you can do. And we can, this is cool. Okay, and then we're going to be checking previous happiness reports. Changes, blah, blah, blah. Here is health, life expectancy over the years. So here we're using the KDE plot. It's one of the plots we were watching at one point. And here this is using just pandas, what it looks like. Just freedom. It's a very long notebook. A lot of things. But yeah, this is just, all different kinds of things you can do. And this one, okay, so here we're using k-means clustering. So k-means is one of the simplest unsupervised learning algorithms that solve the well-known clustering problem. So this is kind of using we're using the sklearn.cluster. Cool. Let's see. Did we look at this one already? No. Yeah, here's just a different one. And this one uses pandas profiling, which is apparently a cool one. I've not used it myself. And it even shows how to install this and stuff. Period. before duplicates, after duplicates, pandas profiling and profile report. And this one gives like a little bit of, yeah, this is what you get with the pandas profiling. So gives you this like interactive, you can number of variables, number of observation, missing cells percentage, duplicate rows, alerts, country of origin has high cardinality, 160 distinct values. Overall rank is highly overall correlated with score. GDP per capita is highly correlated with overall rank. So it gives like, it does your job for you a little bit, you know? There's a lot of different things. And we can even look at, okay, this one goes, yeah, variables. And you can even look at them by interactions. It even makes graphs for you. Don't just return this for it, okay? Like, don't just put pandas profiling on your project. But you should look at it and see what it gives you. But don't use it for the project. This is very cool. And then we're doing a little more describe. Yeah, that's about that is. All right. Anyone have any questions on the project? Anything on Kaggle? Finding this? Setting up your environment? Questions on the homework? Anything you need help with? Even if it's from the first class, you can ask a question. Everybody is all set for the project. The homework, the scavenger hunt, is due end of the week. Don't forget about that one. Where is it? It's in here. Scavenger hunt. Any questions on this one? How do you share the Python scavenger hunt? So you can just ping it to me, or then I did create a. I think I put it in Slack. Let's see. You can submit it on this form as well. And if you have issues with that form, just ping it to me. Either one works. Any other questions? Everybody have everything good for the project. I want to make sure that your environments work, that you're not going to be scrambling and stressing about things. Obviously, you still have next week, and you can ask questions on Monday and whatnot, but you know, more time. Even though I'm very much a procrastinator, but I don't want you guys to be procrastinators. No questions? Everybody is Python experts. And I will share this. Make sure this one is download. So you'll have links to what we went through. Notebook, yep. Cool. Okay, if there is no questions, that's all I had for today. Everybody good? All right, I will see you guys on Monday. Last week, our last class. So we have 2 more classes left. Your scavenger hunt homework is due end of the week. Your final project is going to be due end of next week, so end of the class. And yeah, that's it for tonight. everyone.